Okay, so this is what we're doing today. We're going to be using multiples of larger numbers. And that's one of the reasons why I wanted to sort of show you the idea that some of these larger numbers can be broken into smaller into smaller factors. So if you look here, we're going to multiply using factors by filling in missing numbers in a box. So here's an example. They've got 132 times 25, which is the same thing as 660 times 5, because they took 5 from the 25 and multiplied it by 32, which gives you 660, right? 132 times 25 gets you the same answer as 660 times 5. Just the same as 3 times 24 is the same thing as 9 times 8. It doesn't matter which order you combine the factors in. These two numbers are still 3 times 3 times 2 times 2 times 2. The only difference is 3 times 2 times 2 times 2 is 24, but on the second, the 3 and the 3 are combined to make the 9, right? So that's the same thing that's happening here. So based on that model, Daniel, do you want to try 48? Try A here. 48 times 125 is the same thing as what times 25?
480 times 25.
It isn't, because, okay, what's 48? I need a better drawing tool here. What's 40? What are you multiplying 48 by here?
5.
Okay, so if 125, what are the factors you're using? 25 is going to be one factor.
And
What's
5.
And 5. So what you wanted to do is take this 5 and combine it with the 48, which would make 48 times 5. But what's 48 times 5?
240.
Right. I think you told me 480 the first time. So this is 240, which does work. Okay. But 480 doesn't work. 240 is this answer. Do you guys see how he got that? He split 125 into the factors 5 times 25. And then he took this 5 and he combined it with the 48. And so instead of being multiplied by the 25 now first, it's multiplied by the 48. So now 48 times 5 is 240.